I'll be back tomorrow. That's the plan, as long as nothing really goes wrong. And what you're doing today is you are practicing with an important cell process called cellular respiration. We're trying to be very careful that respiration doesn't just mean to breathe. And so right now you're going to be on page A27. So make sure that you're with me on page A27. And you're going to start exploring how respiration is regulated or controlled. But that's a really difficult concept because you have to first understand what respiration is. And so what we're going to do is we're going to start with remembering important knowledge. Before you work in your lab group, you need to have completed these remembering important knowledge. And then you're going to go to your lab and you're going to set up a lab. This one's a little complicated, so don't be afraid to ask for help. A slight difference is that this lab is not going to contain yeast and apple juice. This is going to contain yeast, sugar, and water. If we have time tomorrow, then we'll do a setup with apple juice as well. And so what's going to be happening is that you need to record an initial observation and a final observation, and then describe what happened and why. You're going to have a lab sheet that has all of the directions, but I wanted to show you a little bit about what we're talking about. This is called Erlenmeyer flask. And what's going to happen is that you're going to fill it up with a certain amount of water, and then you're going to add yeast to one of them. And so there's a bag that's labeled just yeast. The other, you're going to fill up with the same amount of water, but this one you're going to add yeast and sugar. Now here's where we have to be careful. Yeast is a living thing, but right now it's actually in what's called suspended animation. If you've ever made bread from home before, you use yeast. Yeast is what makes the bread rise. And the reason that the bread rises is because it produces a gas. Next time you eat a piece of bread, look at it. There are these little holes in it, and those holes are where there was a gas that was produced by the yeast. And that's what made the bread rise. And so what you're doing is taking an organism, yeast. It's in suspended animation, kind of like a coma. It waits there until it has good conditions to live. Kind of like how a seed doesn't grow until it's warm and there's sunlight and there's water. And so these yeast aren't going to do anything until it's warm, they have water, and they have a food source. And so you're going to put in one of these flasks just yeast and water. The other one, yeast, sugar, and water. We should anticipate that the sugar would be food for the yeast. And so next we need to warm it up, and that's why you have a hot plate. But we don't want to boil it, because boiling it will actually denature the enzymes that the organism needs to live. So we're going to be putting these two flasks on the hot plate, and we're going to turn it to about number 4. Now make sure, and you can see mine didn't come on, I didn't have a little light come on. This means that it's not plugged in or that plug isn't working. So you want to make sure that you have it plugged in, but watch the cord, watch that you don't trip over it. And you never want to turn it on until you actually have your prepared experiment on top of the hot plate. And so what you need to do is follow the directions to fill it with water and yeast or sugar. And then you actually are going to want to trap the gas. And so we're going to use a balloon to do that. And I want to make sure that you see how to do this. Sometimes it helps to have someone hold the flask, but you want to stretch the balloon out a little bit, and then open the bottom of the balloon and put it over the top of the flask. And so right now you can see that there's a tiny little bit of air here in the balloon, but it's forming a seal. No air can get in and no air can get out. You're going to have a balloon on both of your flasks. You're going to put them on top of the hot plate and turn it to number 4. Now you see the lights coming on. It tells you that heat will come out. If you turn it higher than 4, then it'll get too hot, boil, and kill your yeast. And so you're going to let your yeast perform their actions. And while you're waiting, you're going to be completing any other part part of A27 that you can. And so if you look ahead, you'll actually see that the next part is asking you to list 2 ways you think you can increase the rate of this reaction. If we have time tomorrow, we'll actually do this lab again. Then you're going to compare 2 different bread recipes. So we're not just sitting waiting for the experiment to happen, we're actually working and measuring time. You're going to measure how much time it takes for the balloon to fill up with air so that it stands up. Last point, once it fills up, then you need to go ahead and take that one off of the hot plate. It might be a little warm. Don't touch the bottom, only touch the top where it's not as warm. And then go ahead and take slowly the balloon off the top. If you need to let the other one stay on there because the balloon hasn't come up, that's fine. But as soon as the balloon stands up, you need to take them off so they can cool. You'll throw the balloon away, and then you'll dump the yeast down in the sink. You do need to really rinse out the beaker, the flasks, and rinse the sink out, and then put everything back on the cart. However, be careful. Your hot plate might be hot. So this is why it's important that as soon as your balloons stand up, you take them off so that you can turn your hot plate off, unplug it, and let it cool by the end of the class period. And so then you will have performed an example of a cellular respiration model. Your yeast are going to be performing cellular respiration. They'll be consuming something and producing other things. So make sure that you get all cleaned up before the bell rings and that you have time to take your quiz. Hopefully I'll see you tomorrow.